Athlete-centric points-per-game analysis via multiple linear regression. This dissects the ramifications of multiple linear regression administered on a basketball archival dataset that provokes the average points a player scores per match, tailored to the hypothesis of MLR that are not potent to a violation and that researchers can deal with or mitigate if defined. Conventional NBA player evaluation metrics revolve around the disparity in total or pace-adjusted linear combination of box score statistics, such as points, rebounds, assists, etc. In this scheme, however, the variables will zero in on the respective athlete's potential, with the outcome of the game still in question. Hi, my name is James Patrick Ryan A. Pasaforte. Table of Contents, Introduction, Review of Related Literature, Methodology, Results, and Discussion. Introduction. To distinguish which NBA players strive to secure their team's victory is perhaps the recurrent question in basketball analytics. One might quantify that the notion of points per game or field goal percentage is what equips basketeers to triumph. Yet, the coach ought to condition and oversee the routine hurdles on players throughout the competition, a complex process that sets a vast dose of physiological stress on the athletes. Moreover, this tedious affair supervises the contrasts in work demands introduced among position-specific contest behaviors and player status, and adjustments due to various constraints as with injuries. Hence, continuous development and surveillance in drill sessions and individual capabilities are vital to optimize. Basketball capacity, in essence, relies on shooting two-point field goals and securing defensive rebounds. In hard-fought games, however, fouls and free throws exhibit increased gravity to deduce the match success, contrary to lesser challenged ones. As luck would have it, they do not incorporate elements on top of offensive rebounds, turnovers, steals, and assists that discriminate variables for wins and losses, which sanctions our dataset that does not embody these labels. When weighing the best and worst teams, the ultimate aspects for habitual success are associated with assists, steals, and blocks, an attestation of the influence of passing and defensive skills across the exterior and interior court spots. The systematic investigation from NBA data likewise documented that game upshots harmonize with superior offensive efficiency in detail, points banned in the third quarter, and the defensive variables of fouls and steals. Thus, as anticipated, it signifies that both offensive and defensive variables are crucial. These interpretations are factual on a team-level basis. However, a necessity exists to embark on player-level analysis to perceive what variables diverge elite contenders from others. Perhaps Amiller expands the boundaries that foster discernment of match conduct and embraces a holistic approach to sports behavior scrutiny. The researcher did not utilize rich data that touches on basketball profiles for distinct sportspersons and lineups, yet the free throws and field goal percentages operated as a baseline reference to estimate their points per game. A thorough explanation of these performance profiles at hand, via objective benchmarks, would suffice as a gauge to hone routine and refine playoff execution in the long run. In the NBA scene, they execute this end via the sensational essence or attributes of the game from the awarded players that constitute the first, second, and third teams, all-stars, with the statistics of the rest. The panel of sports writers and broadcasters orchestrates the selection of the all-star players from these three squads. The players acquire 5 points for a first team vote, 3 points for a second team poll, and 1 for a third team. In due course, and to account for positions or roles, the 5 players with the highest point tallies assemble the first team, the successive 5 draw up the second, and the remainder the third team. One of the most sophisticated contrivances in basketball performance assessment is player tracking technology. It wields computer vision geared with algorithms adapt at player stances calculation with a sample rate of 25 or so frames per second. The induction of kinematic variables such as distance, velocity, or acceleration is viable from this data, and sample frequencies might revamp from now on. At this juncture, the technology operates on data from the notational analysis that hand compound enlightenment on an activity that embraces physical exertion and skill. For instance, the respective distance an athlete traverses when they attack and defend the rim. The groundwork in basketball, through positional-derived variables, curves to bite-sized samples of teenage athletes, weighed on physical demands, effects of defensive strain on motion response, and how workload overwhelms tactics. Kinematics, or motion of a system of bodies of tracking data, complement variables from the physiological, technical, and tactical domains that elicit a thorough world picture and grip of sports in its entirety. As mentioned in this dissertation, the technology applies big data with individual basketball game enactment profiles across partakers and teams. they reckoned that all-star players would outperform the non-all-stars statistics-wise. Methodology. Linear regression is a statistical technique that models the correlation or affinity between a single dependent variable or scalar response and one or more independent or explanatory variables. In this endeavor, however, the latter is utilized to pinpoint the relative influence of one or more predictor variables or regressor on the criterion variable or regressand and outliers or anomalies. So, here's the equation. Linearity. A premise for a precise approximation that there exists a linear relationship between the predictor and the response variables. The researcher employed this to bypass the miscalculation of model underfitting, a grave offense that we can't overlook. The data points shall rest on or around a diagonal line within a scatter plot. Multivariate normality. This assumes that the model's distribution of error terms is normal to dodge the issues with confidence intervals, which is it might sink or inflate. Through a histogram and the p-value of the Anderson-Darling statistical probe of whether or not a dataset materializes from an established probability distribution. No multicollinearity. This presumes that the predictors employed in the regression do not correlate as in the matrix, although if dismissed, it doesn't hint that the model is to no purpose, yet renders interpretability drawbacks of the coefficients. The researcher utilized a heat map of the correlation as a visual aid and examined the variance inflation factor. It computes the behavior or variance of an independent variable influenced or inflated via its affiliation or correlation with extra independent variables. In effect, VIF gauges how much a variable plays a part in the regression standard error. No autocorrelation. Autocorrelation emerges when the residuals are contingent on everyone. The researcher utilized the Durbin-Watson, or TW, to diagnose whether a positive or negative correlation stems from a statistical model. An adequate numerical quantity for TW is within the scale of 1.5 to 2.5. Do not overlook a few hints the model is obliged to seize. Homoskedasticity. Homoskedastic propounds the state of affairs in which the variance of the residual or error term in a regression model is constant. Hence, the error term does not vary as the predictor variable fluctuates. If neglected, the confidence interval is either too expansive or thin. The researcher plotted the residuals to observe whether the variance emanated stable or uniform. Basketball dataset. X1 height in feet, X2 weight in pounds, X3 percent of successful field goals out of 100 attempted, X4 percent of successful free throws out of 100 attempted, X5 average points scored per game. Results and discussion. The initial effectuation of MLR on the dataset yields an R-squared coefficient of determination regression score function of negative 0.09556721961349468. The rule of thumb is that the value is duty-bound to lie across 0 and 1 inclusive, but possible to exceed beyond that parameters. It might seem bizarre as the accustomed means to diagnose R-squared is the fraction of variability the model accounts for in the scalar response. Second, it proffers the mathematical intuition that a quantity R is squared. Hence, whichever negative numeral to the power of 2 is positive, come what may. Either way, R squared is equal to the interval notation 0 and 1 inclusive, or at the very least, non-negative. Apart from the definite instance of a linear regression model with an intercept term, R squared is in fact not equivalent to the square of a particular numerical quantity which divorced the inference above stated. It is the ratio of the mean of the squared errors to the variance of the dependent variable subtracted to 1. As it is infinite how flawed or inferior a model's conjectures can be, it's feasible for this ratio to become arbitrarily massive that if deducted to 1, issues a negative difference. In practice, the negative R-squared manifests that the model's predictions are worse than a constant function that on every occasion or without fail anticipates the mean of the data. Linearity. This is the depiction or portrayal of the actual versus predicted values. In the Prosodom scatter plot, the dispersion of data points is at a glance high, an infraction to the postulate or assertion that there exists a linear correspondence between the predictor, regressor or explanatory, and the response, regressant or criterion variables. One telltale token of this violation is if theta values plotted against residuals furnish an eccentric or odd parabolic pattern, like so. Multivariate normality. As apparent or evident in the histogram, the distribution of the regression equation residuals or noise is shear normal, and the p-value of the Anderson-Darling triad for diffusion adequacy is 0.3350 66 04 58 46 62 06 4 delineated in the Colab notebook. Hence, a premise assurance. No or little multicollinearity. Here are the variance inflation factor for each variable, and 4 cases of viable multicollinearity emerges. Meanwhile, 2 cases of irrefutable multicollinearity. Whence, the coefficient explication is tricky. A predicament has the degree of correlation between explanatory variables is intense. It denotes that alterations in one variable are associated with shifts in variables further. The coefficient rates are in essence susceptible, as they tend to vary in unison, which upfront diminishes the model's prowess. No autocorrelation between residuals or error terms. The Durbin-Watson of the residuals or disturbances is 1.2088040490864564, a symptom of positive serial autocorrelation that induces erroneous or off-target least squares estimates, as there is a notorious temporal component on how to draw affirmations. Homoscedasticity. This is intricate, as we can perceive a somewhat static or uniform variance across our residuals. Conclusion. As far as one can divulge, the dataset utilized throughout the exploration violates several surmises or assumptions, which stir focal pitfalls with model coherence. Although these are prevalent in real-world data, even so, it is pivotal to ascertain the hypothesis and disseminate the model's inherent deficiencies for this course, as it is risky to glean or formulate a rational conclusion hinged on made-up figures. Furthermore, it pushes a false sense of security as one tackles empiricism when it mandates due diligence prior or right off the bat. Moreover, non-parametric or distribution-free statistics at one's disposal are cherished resorts or fallbacks when omissions of the hypothesis are inevitable. We might affix polynomial terms to the predictors or employ nonlinear transformations to rectify linearity. When the error term's continuous probability distribution deviates from normality, restrictive solutions comprise the eradication of residuals, but with caution or attention to detail. To meld multicollinearity, eliminate regressors with excessive variance inflation factor or enforce dimensionality reduction. When autocorrelated noise or disturbances perpetuate, the curative did is to pinpoint the omission of a crucial predictor variable. Heteroscedasticity, where regression designates each data point with a weight established on the variance of its weighted value and curtails the sum of the weighted squared residuals. Most statistical pursuits lean upon certain assumptions on the variables employed in the analysis, and if not carried out or brought to fulfillment, byproducts are downright fickle or untrustworthy, and a type 1 or type 2 error, or over or underestimation of significance or effect measures. As Bedford cites, awareness of the circumstances when violations of assumptions lead to severe biases and when they are of little impact is paramount to exceptional data analysis. Thank you.